A confirmation regarding the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. We shall be starting in a couple of moments. No, Pratyaksh. Isostasy is relevant for your optional, and search tectonics, even in optional, it is not asked. So, Raktim, I might not have seen that, my dear friend. I remember last time also I asked you to remind me. I don't have the mail ID that you sent with. So, if possible, be kind enough, get in touch once again. Okay, mention your name and let's see. Apirogenic forces, Devansh, are continent building because you have the entire region basically uplifting or subsiding. So creation of large depressed portions and uplifted areas. That is one of the feature of the continents that we see. That is why continent building. And that is where in apirogenic, in general, you will find many uplands getting created. Hence, continent building. Okay. So, hello, a very warm good evening to all of you, and welcome to Byju's Exam Prep. Welcome to another session of geography, where today we shall be proceeding ahead with the portion of climatology that we had initiated the discussion on in Saturday. Now, in climatology, till now, what is it that we have discussed? So, we have discussed about the evolution of atmosphere, the atmosphere which surrounds the planet Earth, what are the components which constitute that atmosphere, and what is the role played by individual of these components and constituents. That is what we looked at. Then after that, we looked at the various methods by which the atmosphere gets heated or receives its heat, be it first of all the radiative forces from the sun that ends up heating the ground surface. The ground surface, through the method of convection, warms up the air immediately above, and that air eventually moves and expands, and by convection spreads the heat in the rest of the atmosphere. So there is a kind of a transfer of heat from one portion to the other by all these three methodologies. And also we looked at the process of advection, where you have distribution of temperature and heat via the horizontal movement of wind, which does take place, where wind might move from a cold area to a warm area, what we refer to as a cold advection, or it might move from a warm area to a cold area, which is referred to as a warm advection. Then we looked at the concept of lapse rate, where we observed that lapse rate is basically the rate at which the temperature changes as we move higher up. So, as we move higher up in the region of troposphere, we observe that the temperature starts dropping. So, that is what we consider as the environmental lapse rate, which is normally held to be around 6.5 degrees Celsius of temperature drop every movement or every rise by 1 kilometer. Then after that, we looked at the concept of adiabatic heating and cooling, where we saw that this is a methodology of heating and cooling of air, where you don't necessarily need to provide external heat to the air, or you don't need to extract heat from the air parcel. The air parcel in question automatically, by the virtue of expansion or contraction, that is the change in volume, it is purely by that factor itself where the air parcel tends to gain or lose heat. For example, when any air parcel tends to expand, it becomes cooler, it tends to lose heat. And when any air parcel contracts, it tends to get warmer, and that is what is adiabatic compression and adiabatic heating. Then we looked at all the various different layers of the atmosphere and the various features associated with it. So if you have to observe a trend, one of the trends that we have followed both in geomorphology as well as in climatology till now, first we have looked at the formation. In the case of geomorphology, we took a look at the formation of planet Earth. Then we looked at the layers of planet Earth. And then after that, we looked at how the dynamics works between them, whether the layers move, whether there is subsidence, whether there is upliftment. That is how we proceeded. Similarly here, first of all, we looked at the evolution of atmosphere. Then we proceeded ahead, and then we started looking into the various layers of atmosphere. And after that, we are now going to look into the various dynamics around the region of the atmosphere. Now, by the way, this week is going to be very, very important in the sense of the portion that we are going to complete this week. This week, we are going to cover the main crux of climatology. So ideally, I would suggest all of you that kindly carry out the process of revision every day, that we cover whatever we cover on a daily basis. I'm not asking a lot out of you. I'm not asking you to devote so many hours. Whatever we cover in the session, after the class, just manage to repeat that or revise that from the PPT and the additional reading materials. Rest of the materials revision you can do later on as well. Now, another thing before we proceed, that this Saturday and Sunday, that is the past Saturday and Sunday, which recently passed by. So I hope that you would have seen the objective and the subjective questions which were uploaded for the test for the portions that we have covered till now. Now, many of you have written the subjective answers and have written it very, very beautifully. And you have basically written what is supposed to be written in a subjective answer. So all the well done and good job to all of you. And the rest of you who have not taken up the test, kindly take up the test, and that consider that to be a kind of an assessment about which are the portions that you still associate with, which are the portions which have long escaped your memory map, and try to recollect them back. So use that, and that is how you will be able to revise properly. Having said that, when we discuss the mains answer writing again in the portion of climatology, there again we shall be talking about the bits and pieces about what constitutes an answer. Okay, now here, when we talk about the other portion, now we start with albedo. So today we will be starting with albedo. Then we will be taking a look at the various portions of heating and cooling, various facets when it comes to heating and cooling. What is it that temperature depends upon? Temperature inversion. And then eventually we'll move on into the important area of air pressure, expansion of air, contraction of air, movement of air, permanent winds, pressure belts, and so on. So we start with the portion of albedo. Okay. So when we talk about albedo, what is albedo? It is, in simple words, albedo gives us an idea that any surface, how does it interact to or how does it respond under solar radiation exposure. So for example, any surface, when solar rays they fall on any surface, there will be some amount of that solar rays which will be reflected back, some amount which will be absorbed, right? Any particular surface, be it the road, be it the houses that we live in, be it the roof of the houses, be it your vehicles, every surface will have some reflection, will have some absorption. So that feature which each and every surface will exhibit or indicate, that is albedo. So albedo is the measure of the reflectivity of solar rays from any particular surface. So it is the portion of solar energy reflected from the surface of the earth back into space. So here, when we consider, let's say, when we consider any particular surface here, so when the light rays, they fall on that surface, some part of that light rays, they are absorbed, some portion of that light is absorbed, and then some portion is reflected back. Okay, so the temperature indicates what is the temperature that the surface will experience. That temperature in itself is dependent or is driven by many different factors. So the temperature that the surface will gain, that will be dependent on the amount of sunlight that is absorbed. So this portion that is absorbed solar energy, absorbed solar energy, that gives an idea about the temperature of the surface. But the measure of albedo is what is the proportion of solar rays which have been reflected back. Okay, now albedo is a measure which lies generally between 0 to 1. It is a measure which lies between 0 to 1. Now in that case, if an albedo or if any surface indicates an albedo of 0, that means no reflection. That surface will absorb every bit of the solar rays which are falling. And then when you have the albedo of 1, that indicates complete or 100% reflection. So when you have whitish surfaces, brightish surfaces, generally I hope we are aware that on a brighter surface, light tends to bounce and reflect back. On a darker surface, light will be absorbed greatly. That is why they appear darker. So when you have a whitish surface, for example, this ice cover, now when the sunlight will fall here, majority of it will be reflected back. So snow-peaked areas, snow-covered areas, in many of the areas, they have the albedo of close to around 0.8 to 0.85. So snow-capped areas sometimes, snow-capped areas, they will indicate an albedo of roughly around 0.8. So if 0.8 is the albedo, means what? Means 80% of the solar rays, they are reflected back. This means 80% of solar energy is reflected. Around 20% is absorbed and around 80% of it is reflected. Now, in the first figure, the topmost figure, we had also looked at the fact that absorbed solar energy gives you an idea about the temperature of the surface. Now, if the albedo is high, if the albedo is closer to the portion 1, that means there is a greater amount of reflectivity. And if what follows after that is, if greater amount of solar rays are reflected, means lesser amount is absorbed, and lesser amount is absorbed means what? Lower temperature, cooler surface. Conversely, if you consider a marshy area, conversely, if you consider an area which has the presence of grasses, marshes, etc., Now, this is generally darker in appearance. Now, here, when the sunlight will fall upon this, only some part of it will be reflected. Significant portion will be absorbed by the ground surface. So, as a consequence of it, it will have an albedo roughly around 0.2 to 0.3. So that means only 20 to 30% is reflected, whereas almost 70% is absorbed. Now, if you have a greater absorption, that will always end up initiating what? A higher temperature. That is why during afternoons, generally you will observe that during afternoons, if you go out, step outside your house and you find the normal roads, which are generally darker in color, try one thing and put your finger on the road and sense the temperature. You'll find that the roads are very, very hot during afternoon because they have experienced sunlight throughout the day. So that is why they become scorchingly hot and burning hot almost, right? On the other hand, if you have a house next to the road or if you have a building next to the road, which is, let's say, whitish in paint from outside. Now, whitish surface means it will reflect more light. So if you try to touch the walls of that white painted building, you'll find that compared to the road, that building wall will be cooler. That is why you will find that in all the various different warmer areas of the entirety of the world, wherever you have high amount of heat which is observed, in all those areas you will experience that the walls, they are painted whitish or in a brightish color, so that majority of the sunlight is reflected back, very little amount is actually absorbed. Now, this is the case of albedo, real life implication of it. But then when we talk about larger areas and implication in larger areas, when you consider plateaus and plateau regions which have darker appearing rocks, darker colored rocks in general, that also significantly absorbs heat, because once it is dark, albedo value will be less, means the amount which is reflected back, that will be lesser. So that is why those plateau areas and the rocks in those regions, they get very, very hot during the summer season, whereas the cooler areas, the ice-capped regions, due to the reflection of the sunlight, they manage to remain cooler for a larger period. Okay, so that is the factor of albedo. And albedo, the role of albedo as a concept is it helps us understand about the role that the surface plays, the type of surface, the role that they play in determining the temperature in any area. Now, albedo has got another implication, and something else can be understood particularly easily with the help of this concept of albedo. And that is about the polar melting and increased polar melting, which is observed particularly in the region of Arctic. Increased melting in Arctic. Sand reflects very little amount of solar rays. White sand is still brighter. Sand does not reflect lot of solar rays. It will also have a lower albedo. Okay. Now, increased melting which is observed in the case of Arctic or in general in many portions of the world, and there you will have the role played by the feature of albedo. Now, how? So once you consider water and compare it with ice, so obviously ice will have a higher albedo. Ice means greater reflection, right? Water is darker, means it will start absorbing more. It will absorb significant amount of solar rays. Now, ice is also of varying thicknesses, different types of ice. Even when you open up your fridge, refrigerator, now that the summer season is coming, you will have this increased utility. So when you open up the refrigerator, and if you have put ice in the ice tray, there also, you will find that few of the ice blocks which have significantly frozen, they are whitish in appearance. Whereas few of them, which have not yet frozen to that extent, you'll find there's a transparency in appearance. They are not that white. So ice sometimes will give you the appearance of absolute whiteness, as you see in this case. But sometimes when the ice is thinner, then it will appear a bit transparent of sorts. So, which of them will reflect more? Will the thicker ice be able to reflect more, or will the thinner ice be able to reflect more solar rays? What do you think based on the coloration? Very simple. Always thicker ice. Thicker ice will be able to reflect more because it will be more brightish in appearance. So thicker ice piece, thicker ice generally has got a greater reflection, right? Because it is more brighter, more whitish in general. So here, when you have the solar rays which fall in, it will be reflected back. Because we have seen earlier, ice has got an albedo 0.8, almost roughly 0.75 to 0.85 is the albedo number of ice. Now, that means 80% is reflected. But then, why I have taken the case of Arctic? Because Arctic is particularly unique. Now, I'm not going to ask here, and I'm not going to risk it that how many of you are aware about it or not. Those of you who are aware, fair enough. Those of you who are not aware, now is the high time in your life that you should know that when we consider Arctic, Arctic is not a continent. It is not a continental landmass. Arctic is a water body. And the frozen area that we see in the region of Arctic, that frozen area is basically ice above water body. So in the case of Antarctica, you have land mass over which there is ice. But in the case of Arctic, you have a water body. Above that, you have ice. So in the region of Arctic, when you have increased heating due to global warming, etc., what that initiates, first of all, is that the ice starts thinning out. The thicker ice which was present ideally, that starts to become thinner. Now, when the ice starts becoming thinner, it will start absorbing more heat. And when it starts absorbing more heat, in fewer areas, you will have water which will be exposed. Like this, as you can see, water can be exposed in some areas. When water is exposed in certain areas, that region will absorb more heat as compared to the ice. So more heat is absorbed, higher temperature means further melting. So it is a kind of an automatic feedback loop which sets in, where heating further heats up and exaggerates the rate of heating, due to which the rate at which the Arctic region is losing ice is at an exponential rate. So what happens here? Basically, if you have to express it in general, this is the kind of question that UPSC has been asking recently. So you should be aware that how and the same logic will be applicable even in the high covered snow peaks or any frozen area which is undergoing increased melting due to climate change. You will observe there's a kind of a similarity in structure. What? So for example, global warming will lead to melting, or rather than simply saying melting, increased melting. Now, Due to increased melting of ice, obviously, ice will melt. I hope nobody is having the confusion that what is going to melt here. Now, due to increased melting, what do you experience is you will experience greater or water and thinner ice is exposed. Now, when water and thinner ice is exposed, then what happens? Greater absorption. Greater absorption of what? Of solar energy. Okay. Of solar energy. Now, if there is a greater absorption of solar energy, what will that lead to? Increased temperature. Now, when the temperature increases in an area, what does that lead to? Increased melting again. So that is how the entire cycle is self-sustaining. It is a feedback loop, a kind of a vicious cycle, so to say. That is why in the region of Arctic, the rate of ice loss, that is something which is inexplicable. Initially it was very easily understood that okay, due to warming, this is something which is happening or it is melting. But later on it was found out that many regions of Arctic, they are losing ice at such an incredible pace that areas around Antarctica, they are still able to retain some amount of ice, whereas Arctic, that is why the IPCC, in its assessment report, that is the Intergovernmental Panel on Climate Change, IPCC in its report has predicted that by the year 2040 or 2045, there is a high chance that one of the summer months we will get where we will see zero ice in the region of Arctic, because that is where it is sustaining its melting process. And this is driven by the basic phenomena that is albedo. This also works in various other instances. For example, take the case of Himalayas and melting of glaciers and snow in Himalayas. Now, ideally, ice is white, but in the region of northern India, you have many of the pollutants which are darker in appearance. They are released into the air and they go and deposit themselves over the whitish ice. Now, when you have a black deposit on whitish ice, that will start absorbing more because it will reduce the albedo. And suddenly, because there's greater absorption, there will be higher temperature, increased melting, and it will sustain itself. Okay? Now, here, then we come to the factor of heating and cooling of land and water. Now, both land and water in any particular region, they end up receiving equivalent amount of insolation, light rays, etc. But the temperature that they indicate, the temperature that they give out, that is something which is very different. Okay, so you have the conditions of land and water responsible for the varying amount of or the differential heating and cooling that they exhibit. How? Let us understand that. So here, when we consider this, so let's suppose this is water. This is water in the form of sea, and this is your land area. Now, when we have the solar rays which come in, suppose the sun, and the solar rays, they come in. Now these solar rays, they will hit both land and water. But both land and water will respond differently to the solar rays, or they will have different treatment for the solar rays. Let us see how. And here, if you will observe in the region of the land, and this is something that you observe on a day, you can observe on a day-to-day basis as well if you are interested enough or curious enough. Generally, when you observe the solar rays hitting the ground surface, do you think that those solar rays are able to penetrate the ground surface? Do you think that if you keep something 1 meter underneath the ground surface, will that receive solar rays? Absolutely not. So here on the land area, the solar rays and the solar energy which is received, that energy will be restricted where? Only across the surface, maybe around 2 inches, 3 inches, 4 inches underneath the surface. That's it. Because if you take the soil and randomly in your garden, if you go, and here if there is a topsoil, you put your hand underneath that soil and you sense the temperature where up till where your hand can go through, you'll find that slightly the soil is cooler, right? Because majority of the solar rays, they are restricted only up till the above 2 to 3 inches, right? So first of all, in the case of land, solar rays or solar energy is restricted to surface. It might be absorbed, it might be reflected from the surface, but under no condition will you find a scenario or you'll come across a scenario where the solar rays are able to penetrate through the land. That is not the case. But when we talk about water, water behaves differently. Water is transparent. So here, when you have the solar rays which will hit the water, it will not be restricted to the surface. It will start penetrating lower down as well, isn't it? Now, when it comes to heating, that heating will be carried out to the lower region as well, at a depth of water. And also, water bodies have a kind of a circulation that you will observe. Generally, there's a kind of a circulation which is observed in the water bodies. So let's suppose a particular area gets heated up, but there's a circulation, so that heat will be distributed. Also, over water bodies, there is another phenomena which is consistently carried out, and that is evaporation. Evaporation is also a consistent phenomena over water bodies. And evaporation from any surface, if evaporation happens, that surface experiences cooling or warming. What do you think? From any surface, when there is evaporation which happens, that surface will experience cooling or warming. Beautiful. It will be cooling. Anywhere where there is evaporation, that region will cool down. That is why when you perspire, when you start sweating and you stand in front of a fan, suddenly you feel cooler. Why is it so? Is it because the fan is able to generate cold air directly in your face and is able to blast cold air in your face? Absolutely not. All that the fan manages to do is circulate the air in such a way that your sweat will evaporate quickly. Quicker it evaporates, cooler you feel. So evaporation, wherever it happens, it leads to cooling. Now, if I think about how is it that this water will respond to heat or solar energy, I have to understand that if any parcel of water body that I consider, for that, how much time will it take to gain heat by 1 degree Celsius or so on? That will be dependent on factors, that is the water circulation is keep happening continuously. Evaporation of water is happening, further providing cooling. So when it comes to heating out of land and water, you will always find that the land heats up very quickly, whereas water body takes a longer period of time to get heated up. Because in the water body, in the case of the water body, you have heat is distributed, because eventually, as we will study in oceanography to some extent, because in oceanography also for general studies, lot of circulations which happen in the oceans, that is beyond the syllabus. So whatever is in the syllabus that we will study about oceanic circulation, you will find that even in oceanic waters, there is a very significant convection current carrying warmer waters to the lower levels, and or warmer waters to the upper levels and colder waters to the lower levels. And this is something which is continuous. Basically, this is also responsible for the maintenance of life forms in larger oceans that you come across. So, and again, that is something will come into oceanography. So, there, due to the various circulations which exist in the water bodies, you have the heat which is distributed, right? Another factor is consistent evaporation. Consistent evaporation provides cooling. Also, so if I have to basically summarize this portion, let's suppose that what can I conclude about heating of land and water? So when I talk about land gains heat much faster as compared to water. What this translates into in simple meaning is that it will be much easier for the land to raise its temperature by 1 degree Celsius due to the solar energy as compared to the water body. Or it will take much larger amount of time, greater amount of energy for a water body to experience a rise by 1 degree Celsius temperature as compared to the land area. This is during daytime. What about night time? During night, what do we observe? We basically observe the loss of heat. That is what we experience during night time. Now, that loss of heat, will it be quicker over the land or water? So when we talk about the land area, all the heat is restricted to the upper 2 to 3 or 5 inches of land at maximum. All the heat is concentrated there. Whereas in the water body, the heat is distributed. So, for the land area to lose heat, it will be able to lose heat very fast, very quickly. Whereas the water, it will take a larger amount of time to lose that same amount of heat. So that is why land loses heat much faster as compared to water. For example, if ever you have been to a sea beach or a coastal area, during daytime, that is around afternoon, from 12 to 2 p.m., 3 p.m., if you try to walk barefoot on the sandy beach, your feet will almost burn up because that is how hot the sand is. But then when you go into the water, during daytime, water will be significantly and comparatively cooler. It provides you relief. During night time, late at night, if you go you will find that the sand, which was earlier very, very hot, has now become very cold. But the water is still comparatively warmer. So that is the inference that you will get in terms of the temperature realities. And again, in coastal areas, if you come across any region which has, let's say, rocks, right? During nighttime, you will experience that those rocks get very, very cold. But during daytime, when it is exposed to solar rays, it gets very hot equally quickly. So what this means is basically the implication of it, implications on a daily basis or a diurnal basis. You have implications, that is daytime temperature and night temperature. So daytime temperature that you will observe, basically here, the land is warmer than water. And by water body here, just in case that you don't come up with this issue later, let me tell you, by water body here, I mean oceans and seas of this world. I don't mean that in my backyard I have dug out a small pond, but you said it will be colder, but it is still warm. No. I have kept a bucket of water outside, it is not indicating the same property. No. I mean the larger seas and oceans, how they behave. That is what is meant by water. So please don't get very sentimental when you hear about water and start experimenting with your bucket in the washroom. Okay. And night temperature overall, you will find land is colder, not even rivers, only about seas and oceans. Water here, let me write seas and oceans. So land is colder, water is warmer. So that is why during night time, water body is warmer, because it will take longer period to lose heat, whereas land will be able to lose heat very quickly. Then you have the seasonal implication as well. So when I consider the implications on a seasonal basis, what do we have? Now, during the summer season and during the winter season. Now, overall, if a particular area experiences summer season, can we say that during the entire phase of summer season, can we not say that there is an increased rate of heating on an average? Every day the daytime is longer, nighttime is shorter. So we can say that on a daily basis or on a monthly average, we can say that there's a greater heating during summer. During winter, there is a loss of heat. That is why it becomes cold. So during winter, over that entire duration of 3 to 4 months, can we not say that it is a loss of heat, a cumulative loss of heat which is experienced? So in summer months, a particular region, we can say, experiences a cumulative gain of heat, and in winter months, a cumulative loss of heat. Now we know that out of land and water, we know that which gains heat faster, which loses heat faster as well. So that is why on an average, we can always say that in the summer season, when there is a cumulative net addition of heat, land will be hotter and water is cooler or colder in comparison. We can say that, right? Because water will take a larger amount of energy to exhibit the same temperature that the land is indicating. Land might give you a temperature of 43, 45 degrees Celsius. If you are in tropical region, that is country like India, during summer season, what is the temperature that we experience? Easily 40, 45 degrees Celsius. Given how this year is proceeding and progressing, easily we can expect a temperature of 45 degrees Celsius plus. But if you measure the temperature of water in Bay of Bengal or Arabian Sea, the temperature is roughly around 25, 26 degrees Celsius. Sometimes 27, 28 degrees Celsius, but not more than that. So water will be cooler even in warmer areas. Why? Because correspondingly the land will exhibit a change in temperature much easily, right? So water is colder, land will be hotter. Now what about the winter season? In the winter season, what do you experience? There is a loss of heat, a cumulative loss of heat. Now out of land and water, which will lose heat at a quicker pace? Always land. So if land loses heat at a quicker pace, won't the land get colder? Absolutely yes. That is why here you will find land is colder, or let me write it down here. In both these cases, let me attach the caveat along similar latitudes. And here again, along similar latitudes, land will be much colder, is colder, and water bodies are comparatively warmer. Comparatively warmer. Now, this phenomena that we have seen till now about the heating of land and water, that is very instrumental in influencing the temperature across majority of the parts of the world. Majority of the coastal areas across the world, the temperature that they experience is largely determined by how close they are to the water body, larger water body. And also, this ability of water to maintain its temperature, not become very hot, not become very cold, that is very instrumental for the survivability of species underneath that large oceanic water bodies. Many of the species, they depend on this fact. And this also, later we will see in the next module, that this particular factor of the different temperatures that they indicate, that becomes a driving force for various different types of wind patterns, permanent and temporary as well. Okay. Now, Prakash, what is due to oceanic currents? Ocean currents, see, some of these ocean currents, they are influenced by this particular factor, but there is a differential temperature distribution even within the water body. Even when you consider an ocean, the temperature changes drastically from one region to another, from one level underneath another. And there are various such circulations. If at one point of time, let's say your curiosity drives you to this area, even though I don't think the curiosity will drive you to these areas to explore the temperature in oceans, etc. There are many things in life to be curious about. But if someday it drives you, you'll find that there's a circulation in the oceans from the surface level to a depth of around 200 meters. There's another circulation which begins, I'm talking about vertical convection. There's another circulation underneath that, another circulation up to the bottom. All these three, they drive a global circulation across horizontality. So there are multiple such circulations which come into place in the water. So the oceans which appear calm on the surface, that they are anything but calm underneath. That is why they are marked by such numerous circulations that is very important to distribute the temperature across the globe. Now, after this, we come to Manish, how can there be different temperature at the same latitude? Because of the rate at which the land and water they absorb and lose heat, Manish. That is what the entire conversation for the past half an hour, that entire conversation, in case you missed, was revolving around the fact that land and water they behave differently to the heat received, right? So that is why. Now we come across to urban heat island effect. Now, this is another effect which is largely driven by the factor of albedo. Okay, so it is largely dependent upon the factor of albedo. Albedo is what? What is the amount which is re-radiated back or is reflected back? Now, what is this concept? Heat island. Heat island means that region would be heated. If a region is very cold, I don't think anybody in their common sense will call them as heat island. Island means what? There is something which is surrounded by a uniformity. So, in urban areas, which are generally surrounded by suburbs, then towns, then you have rural areas, then you may have forested areas. So, that is the general spatial spread of the urban morphology, as you will see. So, you have the urban area, then that is surrounded by various smaller buildings, areas of lesser population, and so on. So, in general, if you move around an urban area, and let's say you have initiated a movement from the rural area to an urban area, you will observe that as you enter the urban landscape, suddenly it becomes very hot, it becomes very warm. Now, when you are in the region where you have trees, forests, etc., it is colder. When you are in the region of the villages, it is colder. But in the urban region, suddenly the temperature increases, right? So that is the urban heat island. It is in that region where you will experience higher amount of heat in general. So here, urban heat island indicates how you have the temperature. So if you take a look at this, this represents your temperature. Okay, this represents temperature. So basically, observe that how in the urban areas you experience a higher temperature, suddenly the temperature peaks. Whereas in the rural areas, the temperature is very low. If you have not experienced this till now in your life, it is a high time that you experience this. When you go to a rural area and you keep on driving, that is significantly cooler, much more pleasant, and much more survivable. But urban areas, absolutely horrendous in terms of the temperature that they will indicate. So that is the urban heat island. Now, why that happens? That is something we have to understand. Why this process happens or why this process unfolds. So there are various reasons. But before that, we have to understand that how temperature in an urban area can get influenced. So for example, in an urban area, when you take a look at the buildings which are constructed, there's a greater density of buildings. The buildings are much closer to each other. Most of the buildings, they are made out of concrete, isn't it? The roads that you see, those roads will be tarred. It will have tar, blackish color, asphalt, blackish color. The roofs, the top of the roofs, most of the times they are darker in color because again there also you will have a coating of tar to provide waterproofing in the roof. That is why the roofs are also darkish in color. Now, what is the impact of it? This is something which you don't experience in rural areas. In rural household, what do you have? You have farmlands, fields, one or two houses in between, then again farmland, fields, again houses in between. That is where it is spread out. But when you have everything which is darker in appearance, in terms of the structures, in terms of the roads, in terms of the roofs, now in terms of albedo, reflection of light will be less. There will be greater absorption, little reflection, greater absorption. What is the impact on temperature? It will increase the temperature. Immediately the temperature rises up. Then, when the buildings are very close to each other, very close, they form a kind of a closed area. So, wind movement, will it be easier between them, or will it be more difficult between them? Obviously, in between all these buildings, wind will find it much more difficult to circulate. Now, use your own experience. When is it that you have found the temperature to be more pleasant? When the wind is blowing consistently, or when there is a complete lack of wind? When have you experienced that the temperature is more pleasant? Obviously, when the wind is regular. Now, in between all these buildings, not only is there a greater heating because of the factor of albedo, but also the wind is not moving. Due to which, what will happen? Whatever heating is happening in that region, that will not be distributed. If in this area, let's suppose you had these buildings and there would be a lot of heat accumulated in that region. But if the wind would be blowing, the temperature would be very pleasant because all that heat would be distributed. But because of all the buildings, they offer a kind of a resistance. So this wind, which would have earlier moved, that wind is absent. So the heat keeps on accumulating on top of that. But compare that to the rural area, to your villages. Remember the village, the last time that you would have gone to that rural area, remember that? There would always be a pleasant wind, a pleasant breeze movement is something you would always experience. So that distributes heat. Then there is another factor. In urban areas, you will find that obviously the vehicles, the industries, the construction, everything is at its vicious level. So all of them will release greenhouse gases, pollution, greenhouse gases. Due to those greenhouse gases, what will happen? Greater level of warming. Whereas in the rural areas, you don't have to worry about that. The greenhouse gas in prominence in rural area will be what? Methane. When? When all the dung and everything starts decomposing. So that is the unique smell that you get of the villages, and that is what is methane. That is all. It is in urban areas where you get a combination of all of them, right? Then another factor is, in urban areas, nowadays especially, you find there is an increased necessity felt for cooling. Because the heat is so oppressive, you need air conditioners, you need cold storages, you need refrigeration centers. So the need for cooling is immense. Now, when you have that necessity of cooling, you will require what? Air conditioners, large scale air conditioners, industrial level air conditioners. Now, these air conditioners, while they will cool the environment inside, what is the impact that they will have on the outside environment? They will release hot air, right? So air conditioner warms up the environment. It might cool the inside of your room, but if you will analyze, it will warm up the environment outside. Those of you who still have not experienced this, again, high time in your life that you experience this. Stand outside the unit of the air conditioner, the external unit of air conditioner. You will experience that warm blow of the wind or the air. So that is where it warms up the air outside. Now, In a large building in an urban area, easily you will have 100, 150 air conditioners consistently functioning, and you have many such buildings. So that is how all these factors, they lead to an increased heating of the urban area. Moreover, there are lack of green spaces in urban area. Green spaces, they provide natural cooling. How? They provide you with some amount of shade, very required amount of shade, right? Now, on top of that, when you consider the trees, when you consider the plants, they consistently lose water into the atmosphere. Through the surface of the leaves, they will lose water into the atmosphere by a process which we refer to as transpiration. By the process of transpiration, they will consistently be able to lose heat into the atmosphere, right? So that again provides a indirect rate of cooling. Now, in urban area, you don't have green spaces, so what will provide that cooling? In urban area, you have concrete jungles which are there. Everything is made out of concrete. There are no open spaces which are available. So all these factors lead to the creation of the urban heat island effect. So these are your reasons. First, darker surfaces in the form of asphalt and rooftops in the urban areas, what do? They absorb more heat. Then lesser movement of winds, what do? Leading to lesser heat dissipation. So as a result of that, concentration of heat. Okay. Then lack of green cover leading to lesser cooling. In urban areas, there is a lack of green cover, so there is lesser cooling which is provided. Green cover provides cooling due to two reasons. One, because of the shade that it gives. The second is due to the transpiration which loses water, and that provides the immediate cooling on the surface. It is a different matter that kicks in a feedback mechanism where more vapor in the atmosphere retains heat and so on, but let's not go into that concept. On the base level, it provides a level of cooling. Then lack of open soil regions. That is another minor factor in the urban area. Open soil region. Rarely in an urban landscape will you come across an area which has got large expanses of open gardens and open soil. Mostly it is concretized. If not concretized, there is something which is present there, right? The soil is covered up. And in a country like India, where this demand for space is so high, we are the most populous country in the world. And many of us, we take particular pride in that. So basically, being the most populous country in the world, anywhere there where you find an open space, after a few days, if you go there, there will be a house, there will be associated market there, and there will be 100 people sitting there. So there is no open space, especially in the urban area. Now, what is the role of open spaces? So when you have an open exposed soil area, let's suppose there is rainfall in that region. Now, when the rainfall occurs, that rainwater is absorbed by the soil. It is absorbed by the soil to be later released as evaporation. And again, when that evaporation would happen, it would cool the soil or cool the surface. So that is where, again, that particular cooling is present in the rural areas, but is not present in the urban area. So due to lack of open soil regions, there is lack of evaporation in general. And that means lack of natural cooling. Then greater greenhouse gas emission in the urban area. further leading to the warming effect. Okay, then now greenhouse gas emission from industries, from vehicles, all of them. Greater heating due to electrical and cooling devices. So as many electrical and cooling devices that you use, there is a greater heating which is involved as well. So all these are the reasons or the factors which lead to increased heating in the urban landscape. So what is it that we should do, or what is it that we can do? So basically, that is where you have the concept of green buildings. Green buildings nowhere mean or nowhere infer a building which is painted green. That is not the meaning of green building. Green buildings are those which generally consume lesser amount of energy. They have the natural movement of wind, right? Generally, you will find that the buildings are designed in such a way that natural wind movement is there. So when you have natural wind movement which is there, the use of air conditioners, that reduces. And also in these buildings, there's natural lighting which is allowed, so that you don't need to use the tube lights and the lighting systems throughout the day. So these are green buildings. Then in urban areas, rather than having the surfaces made out of concrete which will absorb all the heat, you need to have surfaces which reflect and re-radiate heat. And also, the city architecture should be designed in such a way that it allows for crisscross movement of wind across the urban area. Whichever urban area, you will observe that whichever urban area experiences wind movement, temperature is very pleasant in that urban area. In India, take the case of the cities of Pune, the city of Nashik, the city of Bangalore. Now, I'm not going into hill stations. Hill stations have a different dynamic altogether. But even if you don't belong from these cities, or if you have never been to these cities, they are particularly famous for the pleasant conditions, weather conditions that they have. Why do they have pleasant weather conditions? Don't they experience pollution? Absolutely yes. Don't they have all the greenhouse gases? Absolutely yes. Don't they have the black coloration due to concrete and road? Absolutely yes. Still they will experience cooler temperature, because the local geography is such, the location is such. There's a gap in the Western Ghats which allows for the cross movement of wind all the way from Arabian Sea. And that is why Nashik and Pune, you will experience not only that, you will experience the fact that whenever there is increased heating for 7-8 days, 8th or 9th day, there will be some amount of rainfall, making the conditions much more pleasant. Same is the case in Bangalore. And this consistent movement of wind keeps the temperature cooler as compared to the other areas nearby. So that is where the city architecture has to develop in a way that it provides for cross ventilation of the air movement. And also, you need to have more reflective surfaces and brighter colored building, right? So that is the aspect of urban heat island, right? Chandigarh, not per se the same impact. Chandigarh, see, now Chandigarh, if you consider, you also have to consider the entire area of Mohali, Panchkula, everything. Once Chandigarh, as earlier it used to be, that is the planned city. So there you had significant wind movement. But since the entire region of Mohali and Panchkula, the entire settlement which has happened around Chandigarh, it has significantly altered the wind movement, and Chandigarh has also started heating up. Okay, right? Now, then we come to how temperature is distributed, or what are the factors which are responsible for distribution of temperature, of variation in temperature as we move from one region of the planet to the other. because I hope we are aware that in different parts of the planet, the temperature that you experience is different. It is not going to be the case that even if I'm in Russia, I will experience the same temperature and same condition as I experience in Chennai. Temperature changes. So, what are the factors? So, first is the latitude of the place, the latitudinal position of the place, whether it is situated at lower latitudes around equator or whether it is situated at higher latitudes closer to the poles. Now, why is it that the latitudinal position of a place alters the temperature? That is because of the fact about the angle that the solar rays make in while falling on the surface. Generally, across lower latitude, solar rays, they tend to fall almost vertically or almost significantly at a higher angle. So that is why lower latitudes, they will get greater amount of heating. Whereas when we talk about the higher latitudes closer to the poles, the solar rays always, they will form a kind of an incline. They will form a lower angle. So that is why the heating will be lesser. So in the case when we talk about the latitude, lower latitude, direct rays means greater heating. Higher latitudes, you have slanting rays and lesser heating. Okay, right? Now, the other factor is the altitude of the place or the height. So basically, we have already seen that when we move higher up, the temperature reduces. The environmental lapse rate, we have seen that closest to the ground surface, the temperature is the highest. As you move higher up, due to lapse rate, the temperature is lower. That is why when you go to the hill stations, if you go to Ooty, if you go to Shimla, if you go to any of the hill stations, you experience a lower temperature. Why is that? That is because you are moving up in height. So that is why greater the altitude of the place, lower is the temperature. Temperature decreases at an average rate of around 6.5 degrees Celsius per 1,000 meter. So any place which is 2 kilometers above sea level, 3 kilometers above sea level, thereby will be significantly cooler as well. Okay, so that is why higher a place, lower temperature. Okay, Biswajit, what is it that you want to understand again? And Yasir, why don't we paint white coat on the roads? First of all, good that you have that problem solving attitude. But painting the entire road white, that is not solving a problem, that is increasing your problem. You will need to get so much amount of paint. First of all, who will maintain that brighter paint? That maintenance cost will be also very high. So the cost involved in doing that, and also understand, road network in India, we are not the most developed country when it comes to the road network, where many areas we don't have the road. What will you do about cooling of that area? Right? For example, consider an urban environment. Take an urban area in India. What percentage of that urban area do you think is covered under roads? You might have a misconceived notion that that might be 50% of the urban area is covered by roads. But in majority of the urban cities in India especially, that coverage is around 5 to 6%. That means if an urban area has an area of 100 square kilometer, the portion under roads will be only around 6 square kilometer. So that hardly solves an issue. latitude and temperature. Okay. Biswajit, see, latitude, when you move closer to the poles, it becomes colder. When you are closer to the equator, it gets warmer. Why? Because around the region of equator, you receive direct rays of the sun. Think about it. When in a very simple experiment, think about it. If you have the surface, and this is something we did last class also. If let's say there's a blowtorch or there is a heat source, which is having the heat fall at this angle, and in the same area, you have another torch, which is significantly tilted, right? Significantly tilted. Now, the tilted one, you will observe that for the heating to be caused, the rays will cover larger pathway. So some amount of heat will be dissipated. Whereas when it is vertical, majority of the heat is concentrated in a smaller area. So in the lower latitudes, you will observe that the solar rays, they are closer to vertical. That is why, take this another example of this. Early morning when you wake up, the sun is up, right? Now, at that point of time, does the sun provide you that amount of heating? No, because the rays are slanted. Even in the evening, the rays are slanted, so you don't feel that heat. But during afternoon, when the sun is almost overhead, you feel a lot of heat because the heat is concentrated. The same is the case with lower latitudes as well. Okay? Right. Prashant, but in Uttarakhand, mountain experience hot during the day. That is true because the insolation is higher. The amount of insolation is higher, but the average temperature experienced is much lower. Okay. Uh, then if we paint the if we paint the road with white color, then won't we get too much reflection? So we get cooler road, but too much. No. Again, the impact that you guys are imagining with the painting of a road, that great impact won't be caused because the roads are very in smaller area. Okay. Suparno, what about Rajasthan? What do you want to know about Rajasthan? Rajasthan is a desert. Rajasthan has got good culture, a very rich heritage, a very good tradition. It has got Rajputana architecture. What about Rajasthan you want to know? Kindly specify if you don't want to listen about the speech on Rajasthan. Okay. Now, here, so, right. We will come to it about night temperature, why the night temperature is lower. And at night, temperature falls much lower in Uttarakhand due to insulation. Okay, guys, insulation is something very different. Insolation is very different. So all the concept that you might have heard till now from various different, I don't know what is the source from which you are hearing these concepts. Insulation is very different, guys. That is something which is used in electrical industry, heating industry, etc. Never ever in your wildest dreams confuse between what do we mean by insulation and insolation. Insolation and insulation, they are completely different. Don't confuse. Whatever source you are referring for your source of information, trash it out immediately, or whosoever you are hearing who is telling you about these terms, close it out. So then another factor which determines the difference of temperature that we experience in various places is the distance from the sea. Distance, or how far that region is from the water body or from sea. Now, how is it that it influences the temperature, or where do we experience that kind of a change? For example, here, when we talk about, let's say, the coastal area, let's suppose, coastal region. Here, let's suppose I consider Mumbai, and here I consider Delhi. Now, during daytime or during summer season, the temperature in Mumbai is around 35 degrees Celsius, right? Nighttime temperature will be 30 degrees Celsius, roughly. During winters, the temperature in Mumbai will be maybe 20, 25 degrees Celsius. Nighttime temperature will be 15, 16 degrees Celsius, right? So summer to winter temperature variation in Mumbai is by how much? Around 10 degrees Celsius. What about in Delhi? The summer temperature might be 45 to 50 degrees Celsius. Winter temperature might drop to 2 degrees Celsius. So there is a greater variation in temperature. There is an annual variation in temperature close to around 45 to 47 degrees Celsius, which is experienced in Delhi, whereas in Mumbai you don't experience that, isn't it? So that is a factor which is driven by the distance from the sea. Coastal areas, you will experience, they have a moderate temperature. Coastal areas experience moderate temperature. Okay. Now, also the seasonal difference in temperature, that is what is referred to as the annual temperature range. What is the annual variation in temperature? That is much lower in coastal area and much more significant in a continental area or an area which is in the interior. So also seasonal variation of temperature variation in temperature is minimal in coastal areas. Now, why is it so? Why is it so that in coastal area we don't experience that great variation between summer winter temperature or that great variation between daytime nighttime temperature? That is because of influence of the sea. What influence of the sea? So here try to understand it intricately because there are combination of factors involved. So when we talk about the coastal regions, on a daily basis, there is a movement of wind from land to the sea, from sea to the land on a daily basis. So there is a distribution of heat. So when there's a distribution of heat, that prevents excess heat from building up in any particular region. Whatever heat builds up through the day, it will get dissipated or dispersed. Again, if there is daily movement of wind, there won't be excessive cold conditions which will be brought about, because then even when the land is cold, water will be warmer and it will bring some amount of heat there. So there is this factor, right? That is daily movement of the wind. So if I talk about the reasons for the same, reasons, daily movement of wind. Now the second factor, if I ask you about two places, that is Delhi and Mumbai, or any two places, one which is present far away from the coastal area, another which is at the coastal area, which of them will have greater humidity or water vapor present in the air? Always you will find that the coastal areas, they are very humid. They are very moist. Yes, perfect. All the coastal areas will have greater water vapor present there because of the presence of sea, right? Now, when you have greater amount of water vapor present in the air, now I don't know how many of you remember this, but we discussed about a sentence that is vapor retains heat. I hope that you have not forgotten it over the weekend. So wherever there is a greater amount of vapor, there will be greater retention of heat. When there is retention of heat, means the temperature is maintained. So in the coastal area, you will have coastal regions have greater vapor presence and that leads to greater retention of heat. Okay. So then why Chennai is hot even though it is in the coastal region? That is why it is hot. Coastal areas, rarely will you come across a coastal area, my dear friend, which is very cold. Rarely. Especially as compared to regions of the same latitude. Coastal areas will mostly be very hot. But analyze why, if you take the case of Chennai, by the time that we are done with climatology, I'm sure you will have better idea into it. But just to give you a brief about why Chennai weather is considered very oppressive, without any offense, no offense meant to anyone. If you want, I can also say that it is the best weather in the world. But generally, it is considered oppressive because of very high humidity conditions and high temperature as well. So, Chennai, for that matter, first, closer to the equator, so greater heat received at lower latitude. Secondly, the general movement of wind during the summer season, the peak summer, the general movement of the wind is not from sea to the land, it is from land to the sea. And during the summer season, while the rest of the tropics or rest of India, during the summer season, there is rainfall which moderates the temperature. Chennai receives that rainfall, its own share of rainfall in the month of November, December, January. So that is where throughout the months, right from the month of later March, April, the heating starts. And the heating will continue all the way till maybe the month of September and half of October. It is after that weather starts becoming pleasant, and during the month of December, you will have good weather in terms of rainfall. Now go to Colombo, Sri Lankan coastline. Now that is even southern from or slightly more south from Chennai. So there the weather is more oppressive because consistently you are moving closer to the equator. If from Mumbai you sit on a flight, you go to Sevastopol. Where is Sevastopol? It again is a coastal city. Let me see how good you are in world maps. So where is Sevastopol? Any idea? Which water body is present near Sevastopol? Very good. Nandamuri, Albin, good. And Surya, your answer is politically more correct because it is no longer a part of Ukraine. So that is something. Sevastopol is the region in Crimea, a city in Crimea, which is in Black Sea. If you go there, the temperature will be much cooler than Mumbai as well. Why? Because you are moving to higher latitude. So the latitudinal extent always has to come into place. But then, as compared to the coastal areas, the areas which are present inland, away from the coast, they are referred to as continental areas. For example, Chandigarh, Ambala, Lucknow, Delhi, any of the cities, Bhopal, Indore, Patna, all of these cities that you take a look into, all of them, Amritsar, all of them, extremity of summer, extremity of winter, right? Whereas the coastal area, summer around 30, 35, winter around 2023, right? 2023, 25. Sometimes in winter, you'll find that in the region of Mumbai, or sometimes even surprisingly, that happens in the region of Andhra coastline, and Tamil Nadu coastline also has started gaining that kind of a trend where in certain December months or certain December days, you see that the temperature is 17, 18 degrees Celsius, but people will start lighting bonfires as if it is so very cold. But in coastal areas, especially in a country like India, it will never get colder than that. Okay, that is where it will be 20, 22, regardless of how cold you think that 20, 22 degrees Celsius is. That is the coldest that it will get, around 18. And then people in the coastal area will start shivering that this year unprecedented cold has happened here. Go to the region which is in the interior, which is not surrounded by water body. Take the case of Rajasthan. Rajasthan during the winter months, they indicate a temperature of 0 degrees Celsius. Why? Because they lose heat. There are dry conditions. Coastal area has got the vapor which is present. Rajasthan has got dry air. It can lose heat like anything. There is nothing to retain heat. So that is why in Rajasthan, if you go to the Shekhawati belt of Rajasthan around Churu, temperature during winter goes to 0, right? So it has got a factor of latitude, distance away from the sea, altitude, the humidity present in the air, everything is related. Now, then we have the factor of prevalent winds. What do we mean by prevalent winds or prevailing winds? These are the existing wind systems in a region. Prevailing is a term taken from prevalent, which is in existence. So that represents existing wind system experienced in a region. Any area, let's suppose warmer, cold winds start coming in, temperature will be cooler. Any cold area, warm winds start coming in, temperature will be warmer. Take the case here of the region of, here again, I will give you the example of around Delhi National Capital Region. Now, around Delhi National Capital Region, during the months of those of you who live in that area, even those of you who live in Punjab, Haryana, Western Uttar Pradesh, Northern Rajasthan, Northern Madhya Pradesh, you would also experience this. Sometimes in winter season, you would experience that the winter is not very cold. There's always this discussion which emerges in the entirety of North India, particularly the area to the top of Tropic of Cancer, that what will be the extent of winter this time. Every day that discussion goes on, from news channel to the television media to people also discussing on the road, that what do you think, this year will it be more cold or this year will it be warmer? Every year that discussion goes. So in the month of December, you would observe in many of the cases that the discussion is, this year it is not very cold, this year it is normal, maybe it is global warming, maybe it is climate change, this year it is warmer. But suddenly one fine day you will experience that the temperature gets very cold. Those people who were discussing, they are not discussing that anymore because it is very cold now. And if you look at the reasons, because cold winds have come from Jammu Kashmir, from the region of Himachal Pradesh, these cold winds have come in this area. That is why Jaipur has become colder. That is why Delhi has become colder. That is why Jalandhar has become very cold. So that is what? Cold winds coming into a warmer area, further cooling that region, right? During the summer days, summer conditions. Again, a property that is generally observed, a phenomena generally observed in the northern part of the country. During the summer season, especially in the afternoon, so in the month of April and May, most of you would experience it, those living to the north of Tropic of Cancer. And as the trends are going, maybe this year by the later part of March itself, you would experience that especially during the afternoon, around 2 p.m. to 5 p.m. If you step out, there is very hot and warm wind which blows, right? And that will increase the temperature. If you get exposed to that, you might catch a fever, you might fall sick as well. We call that as loo. So what is that? A warm wind coming in an area, increasing the temperature of that area. That is what is Lu. So that is what we have as the influence of wind on temperature. So when we talk about influence of wind on temperature, here again, you have the process of cold advection, and also warm advection. Right? Cold advection cools down and warm advection warms up. Okay? That is something which you experience. So these are the factors overall which have an influence on temperature. But not only this. Across the globe, you also have the influence of oceanic circulation, as I was talking about. In all the oceans, you have the oceanic water consistently moving from one part to the other. So this movement, consistent movement of water on the oceanic surface is something that we refer to as ocean currents. We will study later on in the portion of oceanography that what do we mean by these ocean currents, what are the types of ocean currents. But broadly, you can have circulations across the oceans of the world, and this circulation can be in the form of warm water, it can be in the form of colder water as well. So you have a corresponding warm ocean current and a cold associated ocean current as well. Whenever you have any region experiencing warmer waters coming in through the ocean, a warm ocean current, that will always increase the temperature of that region. Increases the temperature. For example, take the case of Northern Atlantic. Northern Atlantic, generally, you are very close to Greenland. Greenland is frozen for most parts of the year. The northern part of Europe is also frozen. But because you have a warm ocean current here in the form of North Atlantic drift, that is why the coastal areas in this region, comparatively, they are warmer, right? Because of the impact of this cold current, this warm ocean current. It is this warm ocean current which eventually moves into the region around top of, to the north of Eurasian landmass, and some portions, some port cities to the northern portion of Russia. That is why they are able to remain ice-free throughout the year. So that is the role of ocean current played on temperature. Similarly, you have cold ocean currents as well. For example, to the western part of North America, you have the cold California current. Now that cools down the coastal area in that region. That provides much needed relief. Also brings about fog and other sea activities in that region. So this again, cold ocean currents, they will lower the temperature of the coastal area. Lower the temperature of coastal area. Ocean currents we'll read in significant detail when we come to the portion of oceanography, guys. That will further cement this idea. Okay, right? Now, so these are the factors which influence the temperature. And when you have to express distribution of temperature or variation of temperature from one place to another, how do you express that? You express that with the help of isotherms. ISO. ISO means what? Similar. Therms means temperature. So isotherms mean those lines which join places of similar temperature. So that is why isotherms are imaginary lines joining places of equal temperature when they are considered at a sea level. So this isotherm is basically utilized to understand the distribution of temperature. If you have 2 to 3 different places, right? If all of them indicate the same temperature, they will be joined by a single isotherm. Okay, so isotherms indicate change of temperature. So this is how, for example, the January isotherm across the globe, this is how they look like. In each of these isotherms, you will observe a corresponding mention of temperature. For example, 20 degree, 10 degree, 0 degree. So that represents that in that region, all the areas which lie on that line will represent 20 degrees Celsius or experience 20 degrees Celsius and so on. So that is how the isotherms are used, the use of isotherms for depiction of temperature. Okay. Now, after this, we'll analyze these isotherms a bit more, but we take a break first. And after the break, we get back. So we get back at, it is 6:42. We take a break. We will get back at 6:55. Thermal equator, wait for some time, have some patience till tomorrow, you will get an idea. It is a kind of the region which has the highest temperature, one of the highest temperature in the tropics. That is joining all those areas, you get a thermal equator. Okay, right? A confirmation regarding the audio, please, if you're able to hear me out perfectly well. Thank you. Now, few of the doubts I will take, and then yes, Nitesh, deforestation, soil profile, that is also important, and then for temperature change, and for government is planning for plastic road. See, when you hear the news story that government is planning for plastic roads, you have to understand it is not never going to be the scenario that the plastics that you use, that is what you will be driving your vehicles on. When we say that government is planning for plastic roads, means plastic will be mixed with bitumen, the waste plastic, so as to increase the durability of the roads and make it much more resilient as well. Vesna, yes, Loo is an example of advection Vesna. Continental character, Biswajit, is basically when a region is surrounded by land from all sides. That is continentality. Gagan, every month isotherm map created and relevance in exam. Relevance is absolutely zero in that case. You need to have an overall idea about what does isotherm represent, and an isothermic map, what does it represent. That is more than enough. Okay, and why wind is absent in urban areas? Mostly, Anil, that is because of the urban architecture that you come across. That is why you have the buildings blocking the path of the wind movement. How does the daily movement of wind affect the temperature of Mumbai? Devansh, daily movement of wind, it ensures the dissipation of heat. It does not allow build-up of extremity of weather conditions. Whereas in continental regions, for example, Delhi, Chandigarh, Ambala, Lucknow, Bareilly, in all these areas, continental areas, which are surrounded by land from all sides, there will be extremity of temperature because there is no moderating influence on a day-to-day basis. Yes, Jasmeet, locations in sea are also included under isotherms. And Suraj, why are isotherms not as parallel of latitudes? Because what do isotherms represent? Temperature change. If the temperature change would have been dependent only on latitude, then the isotherms would always be parallel to latitude. But there are other factors at play as well. We will analyze that. And Gagan, why utensil are mostly silver in color? Having a black colored utensil will lead to lower albedo, thereby faster heating. So you also have utensils, for example, the woks that you have. The woks which are used, if you are getting into the detail of utensils, Gagan, then if you analyze the utensils, also the type of utensils that you have, generally you will find that all those which require very high temperature, for example, the pans, etc., they are darker in color, right? It is the one which is used in slow cooking, that is one which is silverware in general. And Yaramseti, creation of artificial island in mid-sea, that will also provide an increased temperature in the sudden area, in the area around that artificial island, and that will also lead to a bump in temperature. But overall, the sea temperature won't be influenced by these small islands. Sarthak, run of Kutch experienced less temperature in daytime, while the albedo factor that you are inferring to, Sarthak, that is at play. But run of Kutch experiences higher temperature because of the latitudinal extent, because of the direction of the wind movement, and a lack of rainfall, lack of any amount of water. So that is why the temperature is generally higher. Okay? Right? Temperature inversion, Ranjan. Temperature inversion, please explain. So Ranjan, do you want me to explain temperature inversion before the rest of the session? Because till now we have not taken it. So kindly wait. We will come to that. Now we come to the analysis of these isotherms. What can we understand? just by taking a mere look and a mere glance at the isothermal map. Isotherms, they will give you an idea about the temperature change. For example, this is the isotherm representing the month in January. In January, by the way, in northern hemisphere, we will experience winter, and in southern hemisphere, we will experience summer. Now, if you observe the map of the isotherms, you will observe, for example, take any isotherm, take the 20 or 10 degrees Celsius isotherm. So that will represent all the areas which experience 10 degrees Celsius during this point of time. So here you will experience that wherever the isotherm moves, that will be joining the areas representing 10 degrees Celsius. Now, by looking at the isotherms, you also get an idea about the change in temperature in the land area and the oceanic bodies at the same latitude. We have discussed about the differential heating of land and water, that land gets significantly hotter during the summer season, and during the winter season the land is much colder as compared to the water body. We have seen that, isn't it? So what is it that we have seen? If I have to write it down, in winter land gets much colder than water. Now, how is it that we can infer that from the map of isotherms? So let us draw any random latitude. Any random latitude, let us draw. Let us suppose we are considering the temperature change across this latitude. Now take a look over the region of North America. Now I gave you 2 or 3 areas, right? A, B, and over a water body, that is C. A, B, and C, they are on the same latitude. If latitude would have been the only factor controlling temperature change, then A, B, and C would have indicated equal temperature, but they do not. What is the temperature indicated at A? What do you think will be the temperature at A based upon the map of this isotherm? It is the best answer. It will be cold. I am saying the exact temperature. I want to know the exact temperature based on the isotherm. It will be minus 12 and 12.5 degrees Celsius, because it lies on this isotherm, minus 12.5 degrees Celsius. What will be the temperature at B? Very good, minus 25 degrees Celsius. It is on the same latitude. Now let's consider the temperature of the water body at the same latitude. What will be the temperature at C? Perfect, 0 degrees Celsius, right? Because the 0 degree isotherm passes through here. So here you will observe that at the same latitude during the winter season, land areas are much colder. These are land areas, and this is the water body. So that is why you will observe that the land areas are much colder, especially during the winter season. Now again, if you were to compare the isotherms in the northern hemisphere and the isotherms in southern hemisphere, out of both of them, which of them indicate a kind of a parallel nature, a kind of a uniformity in character? Is it the isotherms in northern hemisphere or the southern hemisphere? If you analyze the map, very good, it will be southern hemisphere, right? So here you will observe that in the southern hemisphere, the isotherms, they are much uniform and they are almost parallel to each other. What is the reason behind them? The reason is that in the region of southern hemisphere, there is a uniformity of a water body. Water body is present uniformly all around. So because of that uniformity, the temperature changes gradually and in a homogeneous manner, because temperature changes very drastically over land areas, but it changes very gradually over the water bodies. That is why, because of dominance of water body in the southern hemisphere, you will find a gradual change in temperature. Okay. Sahil, that B is at a coastal region, it should be moderate. But this coast that you see, it is the Hudson Bay, right? So this is extremely higher latitude, very close to the polar region. So that is why there will be cold polar winds which will come here, and that is what will cool down the region. Okay, right? I hope that is clear. Jones, also, you had a similar question. So southern phenomena, basically here we observe that in the case of southern hemisphere, you have a uniformity of temperature distribution, a uniformity of temperature change. Isotherms are parallel to each other because the southern hemisphere is dominated by water body as compared to the northern hemisphere, which is dominated by land areas. So that is why where you have a dominance and a uniformity of water body, there the temperature will change much more gradually, because the temperature changes very slowly over water body as compared to land areas. Okay. Now, this is the thermal image, which again indicates to you that in the month of January, you will observe that the land areas, they are significantly colder. Land areas, they are much colder as compared to the water bodies nearby. And Suraj and another word, Sahil, as well as Jones, all those who had doubt regarding B being a coastal area should be cold, please understand here another concept that you have to understand is that, see, if you have a closed water body like this, almost closed, there the influence of the coastline will not be so significant, right? Because it will not have the property of oceanic circulation, which will provide moderation. So wherever you have open water bodies, for example, Arabian Sea, for example, Bay of Bengal, so in those areas, due to water circulation, heat will be distributed. But in the enclosed areas, heat won't be distributed at the same proportion. Okay? So that is why you will experience that it is because of this differential rate of heating and cooling of water body as compared to land area, that you will experience that as the isotherms move from land to water, there is a significant deviation, a kind of a bulge. In the month of June, it will be something which is opposite, because in the month of January, you will experience, look how the water body is comparatively warmer as compared to the nearby land areas. Land areas are much colder. In the southern hemisphere, observe there is a uniformity by which the temperature is changing. And that is because this is a homogeneous region comprised of a uniform water body. Now, when we talk about the month of July, in this, you have in the northern hemisphere, we experience during this month summer season. And during in the southern hemisphere, we experience a winter season. Isn't it? Now, in the summer season, what do we know in case of land and water? Land is hotter. Land is hotter and water is colder, right? We have seen about that aspect and that concept. Water is colder. Now, if you take a look at it and you compare it, you will observe how the land areas are much hotter and corresponding water temperatures are lower. Again, land areas are much hotter. But again, if you take a look at the southern hemisphere, there again you will observe a kind of a uniformity with which the temperature is changing. uniformity of temperature change because of dominance of water, and over water temperature changes much gradually, much slowly, in a much more uniform manner because the heat is distributed in that water. That is why the isotherms will also be parallel. Okay, now then we come on to the concept of temperature inversion. So till now we have seen about the aspect of temperature change in the vertical manner. What is it that we have looked in the region of troposphere? In the region of troposphere, we have seen that as per the normal conditions of positive lapse rate, the air closest to the ground will be the warmest, and as you go higher up, it will get cooler and cooler, right? We have looked at that fact that air closest to the ground surface is going to be the hottest, and as you move up, it will be cooler, right? Now, that is the normal condition of temperature. Any scenario, any situation which inverts this condition in a way that lower air is colder and upper air is warmer, that is what we refer to as temperature inversion. So, the reversal of normal behavior of temperature in the troposphere, that is referred to as temperature inversion. This temperature inversion is quite common but happens for a short duration in itself. An ideal situation for inversion is still air, where there is no movement of air, so that there is no mixing, long winter nights with clear skies. We'll take a look at all these phenomena, how they lead to inversion. Okay, but in the polar areas, it is a normal phenomena which exists throughout. So what is this temperature inversion again? So here, just like if you were to talk about the conditions, normally in normal situation, what do you experience? In normal situation, you experience that in the conditions of a normal positive lapse rate, what do you experience? You have warm air at bottom, you have cooler air at top, and further higher that you go, you have further cold air. So the temperature is reducing. Now, the conditions of temperature inversion are such where you have cold air at the bottom and you have warmer air at top. Now, what are the immediate implications of this? With regards to the questions that why this happens, we will come to it. But what are the immediate implications? We know that warm air is lighter. Warm air has got a tendency to do what? To rise up. That is why we have the entire convection current, the convection movement in the atmosphere. So under normal conditions, the warm air will always have a tendency to rise up. It will have a tendency to rise up. What about the cooler and the cold air? Generally, the colder air is heavier, and colder air generally has a propensity, a tendency to sink down. So colder air has got a tendency to sink, warmer air has got a tendency to rise. So this is your normal life or normal condition, right? So that is where in the normal conditions, what do you have? You will observe mixing of air, vertical mixing of air. That is the normal life. In the conditions of inversion, you have cold air at the bottom and warmer air at top. Now here, cold air has got a natural tendency to fall down, natural tendency to sink, because in colder air you have lesser energy, so more number of particles will be included there. They will be there present in that air parcel, so it will have a heavier weight. It will try to sink down. So but here cold air is already at the bottom. Where further down will it sink? And the warmer air, which has got a natural tendency to rise up, here it is automatically above. So where further will it rise? So in this case is when we talk about the conditions of inversion. That is when we have no vertical mixing of air. So let's say we have the conditions of pollution. Pollution is caused. Now, whenever you have that pollution, the pollutants released in the atmosphere, generally they are mixed and you have the pollutants taken away, so that again, the next day you have fresh air which you can pollute, right? So that is what we carry out. That we pollute one day, the air mixes up, next day we pollute again it mixes up, and again we pollute. But then, in the conditions of inversion, because there is no vertical mixing, so that means the pollutants, they will remain in the same place for a longer duration. And that is when we experience conditions of smog, conditions where the visibility significantly reduces, and also the pollutants, they harm us for a longer period of time. So that is what happens whenever you have inversion. Now, this inversion is caused by variety of conditions and various characteristics. So based upon how this inversion is caused, you have the types of temperature inversion. Types of inversion. This classification is done on the causes or the basis on which this inversion is happening. So you have surface inversion, then we have subsidence inversion, then we have frontal inversion, and then we have another major one, that is valley inversion. These are the types based upon how this inversion is taking place. So while analyzing, in each of them, the condition is the same. That is cold air at bottom, at surface, and warmer air on top. Okay. Now, let us take a look at each one of them and let us try to understand when it happens, why it happens. So we start with surface inversion. Surface inversion is when the surface loses heat. That is the factor which leads to the air closer to the surface becoming cold. So it is the purpose, or it is the act of the surface to lose heat very quickly. When is it observed? Observed during. Now, in this case, by the way, let us move step by step. I want your answer in all of this. Vijay, my dear friend, a humble request, please don't paste the same question 15 times. Difference between cold and cooler. Colder is much lower temperature, cooler is slightly warmer as compared to cold. That is the difference. Something which is cool, something which is cold. Cold is much lower temperature. Now here, when we talk about surface inversion, this happens as the surface loses heat. Okay, so understand the process. Surface loses heat, When the surface will lose heat, by what mechanism will it lose heat? How is it that the surface tends to lose heat? By what process? Let me see. Very beautiful. Beautiful. So it is by terrestrial radiation. And also by the process of conduction, where it transfers heat to the layer immediately above, the air immediately above. So surface loses heat basically by terrestrial radiation. Okay. Now, when the surface loses heat, it will become cold, very cold. Now, the air directly in contact with the ground surface, that will be influenced by this temperature. So air directly in contact also or becomes very cold, isn't it? The air directly in contact also will become very cold. Now, when that becomes very cold, it will be colder as compared to the air above, because here in the above layer you have no mechanism for that cooling to happen, but in the lower layer, because it is in contact with the ground surface, that will cool down very quickly, so leads to inversion. Now, let me know certain facts and think about it. Please don't be afraid to reply it incorrectly. Wrong answers, they help you understand the fact much better. So don't be afraid, don't be worried. Now, when we say terrestrial radiation and the process of conduction is at play when you have the surface to lose heat. So when is it that the terrestrial radiation will allow the surface to become much colder? Will it be during the short summer nights, or will it be during the winter nights, when winter conditions, when the night time is very long? When do you think there will be more loss of heat? Very good, most of you. So you need long winter nights. Why? So that for a larger duration, that terrestrial radiation will continue to lose heat from the ground surface. Anyways, night time is longer in winter months as compared to summer months. In summer months, the daytime is longer. In winter time, the night time is longer. So night time means loss of terrestrial radiation, hence cooling, right? Now, what about the cloud conditions? Will there be a greater loss of heat when there is clouds, or will there be a greater loss of heat when there is clear sky? What do you think? Perfect. So there will be greater loss of heat when there is clear sky. When you have cloudy nights, the clouds retain heat by reflecting the terrestrial radiation. So clear skies. Now, when is it that loss of temperature will be much more sustained and effective? When there is wind which is present to dissipate and transfer heat, or when there is an absence of wind, so that whatever is happening continues to happen. So will there be a presence of wind required or a lack of wind? Beautiful. Absence of wind, calm conditions, absence of winds. So it is in these conditions where during nighttime, particularly in the tropical regions and the higher latitudes, that is when this inversion takes place. Now, in the polar areas, the ground is so cold that almost throughout the year during night time, you will experience this kind of a surface inversion. That is why here it is written, it is a normal phenomena throughout the year in the polar regions. Now let us understand how it happens, or what happens actually. So we will consider one of the coldest places in India, which experiences very, very low temperature. Throughout the year, it is amongst the coldest areas where the coldest temperature is recorded in India. Can you let me know the district where one of the coldest temperatures is observed or recorded on an average year after year? Impressed. So, Anil, Deepak, Akansha, Jasmeet, Pranay, very good. Shivani also, Sakshi, good. So it is Dras. Dras near Kargil is one of those areas which experiences very low temperature during the winter months. So, okay, but let's say we take an example of here for easier relation. Let's consider Delhi. I'll not consider Dras because there are mountain and other factors involved as well. Now, here in Delhi, let's consider two different timings. So, 5 p.m. evening time, the sun is almost setting, and 4 a.m. early in the morning when the earth has continued to lose heat. So, during 5 p.m., the temperature at the ground surface will be roughly around 12 degrees Celsius. So, the temperature of air will also be 12 degrees Celsius because it is in contact. So, there will be conduction. Now, let's suppose the air above it, that is at a temperature of 8 degrees Celsius. Let us suppose the air above it is at a temperature of 4 degrees Celsius. Right? So, this is what? A positive lapse rate. Positive lapse rate. And this is normal condition. Now, during night time, there is no source of heat. The surface will continuously lose heat. Let's say by 4 a.m., especially if you're talking about the region such as Delhi. Further north, the temperature will be more extreme. Let's consider Delhi. During the later part of December and early week of January, you will experience a temperature close to 1 to 2 degrees Celsius, especially in the peripheral areas of Delhi. So let's say the temperature at the ground surface is 2 degrees Celsius. So the air immediately in contact with the ground will also indicate 2 degrees Celsius. Now there will be general cooling during the night time, but that rate of cooling will be much more exaggerated on the ground surface. Air is not a good conductor of heat. So air will take much greater time to lose heat, to gain heat as compared to the solid and liquid. That is why in air you will find that air getting warm without an outside interference, that is very difficult. Similarly, air getting cold without an outside interference is also very difficult. So air also will cool down, but not at the same rate. So here, the air at this height will cool down from 8 degrees Celsius. Let's say its temperature has dropped and it has become 4 degrees Celsius. The air above it, again, let's say has cooled down, and here you have, let's assume, 1 degree Celsius. But in this case, the closest to the ground surface, the air which is in contact with the ground surface, that is colder than the air above. So here what do you have? You have a negative lapse rate. Why do we have this negative lapse rate? Because the ground has lost heat. And the ground being colder has cooled down the air immediately in contact with it. So this is the condition of inversion. Okay, so this inversion happens because of the surface losing the heat during long winter nights. Hence, it is referred to as surface inversion. So a surface inversion occurs when the atmosphere at the Earth's surface is colder than the layer above it. That is when the surface inversion happens. Around sunset, ground cools rapidly by radiating heat upwards into the space. The air in contact with the ground cools down by conduction, causing the lowest layer of the air to be colder than the air immediately above. Okay? So that is how you have the conditions of inversion. Now here you might have a doubt that this air here, it is cooling from 12 degrees C to 2 degrees Celsius. But here, why is it cooling from 8 degrees C only to 4 degrees Celsius? So listen to this very, very carefully. When we talk about the ground air, that cools down or heats up because of the influence of the ground surface. because of conduction. So if the ground surface is cold, the air in contact with the ground surface will also get cold. If the ground surface is warm, air in contact with the ground surface will also get warm. But what about the air here? What is its source to cool down or its source to heat up? What is its source? We have seen that the source of heating and cooling is the ground surface. It is the ground surface which gets impacted and then the air above it. Here, this particular parcel is not in contact with the ground surface at all. Now, will the loss of heat here will be greater or lesser? It will be very less because there is no external source of addition or removal of heat. So that is why this air will also cool down, but not at the same exponential rate as compared to the air closest to the ground surface. That is why it creates a situation where this is much colder than the air above. And that is surface inversion. It happens during long winter nights when you have clear skies and absence of wind movement, so that the loss of heat can be significantly for a prolonged duration. Then we come across another kind of inversion which is created, and this is created due to the sinking of air column, and that is what is referred to as subsidence inversion. This is something which you don't observe in India. This is something that you observe generally in the mid to higher latitudes during the winter months. So this is observed in middle to higher latitudes, middle to higher latitudes, and that too in winter. Why in winter? In winter, the ground surface will be cold, right? So that will cool down the air immediately in contact with it. So ground is very cold, and cools down air in contact. Now, how is it that you get a warmer layer of air in this region? How is it that you have the warmer pocket? So that is created by the action of subsidence. So in the middle latitudes, due to atmospheric circulation that we will study very soon, so in the middle latitude, you will experience that there is a subsidence of air in certain areas where you have, let's say, colder air, cold air. Now, cold air is heavier. It will try to sink, right? Now, near the ground surface, you have conditions which are very cold, because we are talking about middle latitude to higher latitude, somewhere around 55-60 degree north and south hemisphere. So here, the air will also be very cold. Now, you have a cold air which is sinking from above. Now, as this cold air is sinking, it is moving into region of greater air density or lesser air density. What do you think? As this air parcel is sinking, is it moving into a region of greater air density or lesser air density? Obviously, greater air density, because air density is highest near the surface and it decreases as we move higher up. So it is moving into the region of air density which is greater. So this air will experience compression or will it experience expansion? What do you think? Will it experience compression or expansion? Good. It will experience compression. The volume will reduce. Now we have seen that when the air is forced to compress, when there is a change in volume, a forced change in volume, there is a gain in temperature due to what we refer to as adiabatic heating. So here you have adiabatic heating. Adiabatic heating. Now this adiabatic heating which is created, what will it lead to in the sense of the air temperature? So this air parcel will have or will experience a higher temperature. So again you have a condition where the air near the ground surface is colder and the air above it is warmer. Now, this is the condition of inversion. But this inversion has not been created because the surface is losing heat. This inversion has been created because a column or a parcel of air had been sinking. It was gaining heat in the process, and that is why you have a warmer pocket. And hence it is referred to as subsidence inversion. So subsidence inversion is caused when a widespread layer of air, it starts descending. It leads to subsidence inversion. The resulting increase in atmospheric pressure leads to heating and compression of atmospheric pressure. In other words, adiabatic heating. Now it occurs in the middle to higher latitude. So let me repeat it once again. Let me repeat the entire process once again. So listen to this very carefully. When we say that there is a subsidence inversion, listen to this. When we say there's a subsidence inversion, so the name in itself tells me that this inversion is caused because of subsidence. Subsidence of what? Of air. So how is it that subsidence of air can cause a condition of inversion? What is this condition of inversion? Ground surface will have colder air, upper one will be warmer. That is the condition of inversion. Be it surface inversion, be it subsidence inversion, be it frontal inversion, valley inversion. In all these inversions, one thing is common, that is you will have colder air near the ground surface and warmer air at top. Now, this phenomena is observed during winter months in middle to higher latitude. So think about, in your mindset while you are imagining a region, think about Europe. Europe experiences this. Now, Europe during winter months will be colder. So, the ground will be colder. So, when the ground in general is colder, the air above it, which is directly in contact with the ground, that will also be colder, right? So, this air will be colder. Now, in certain places, not in every place, only in certain places, there is a creation of a condition where the cold air is present on top, which simply starts sinking due to the heavy weight. Cold air is heavier. So the cold air which is present at top in certain areas due to atmospheric circulation and so on, it starts its natural subsidence or its sink. Now cold air is sinking from top, means it is moving into an area of atmosphere where the air density is very high. Air density is highest closer to the surface. So when an air parcel is coming from top to bottom, it is moving from an area of lower air density to a greater air density. So that means that air parcel will have to naturally compress itself to fit in that region. So that compression of air will lead to generation of heat. Whenever you forcefully compress air, it will always get heated up. So forcefully here the compression is happening. That is going to lead to heating up. But this heating up has happened. Why? Because the air is sinking, there's subsidence. If there would have been no subsidence, no such heating would have taken place. Now this subsidence creates a warmer layer of air. Now warmer air, will it continue to sink anymore? No. If its temperature is higher than the portion closer to the ground surface, it will be lighter. So it will float. So that again creates a condition of inversion, and that is what we refer to as the subsidence inversion. okay, generally observed in the region around northern Europe. And this also historically has created a lot of havoc in that area. The very infamous London smog that you will study about later on in other areas. So, in 1952, London experienced this horrendous condition where the smog, and at that point of time, coal would be burnt openly almost across the globe. So, coal would generate carbon monoxide, methane, etc. And that persisted in the air for a very long time. Why? Because there was a subsidence inversion which was prevalent in the region of London. So those pollutants managed to stay in the atmosphere for so long without mixing. Many people lost their lives, hundreds were hospitalized, and many people were many people lost their lives as well. So that is how this inversion basically results in. While the surface inversion, in the case of surface inversion, you will observe that next day morning when the sun is shining again, it will warm the ground surface, the inversion will be dissipated and normal conditions will be achieved. But in the case of surface inversion, this can continue for 1 week or two at least. Okay, so that is the case of subsidence inversion. Gagan, why the cold air was descending? Because the cold air is heavier in general, my dear friend. That is why the cold air is sinking. Naturally, the propensity of the cold air will be to sink because warm air is lighter, colder air is heavier. Is this practical? The compression of air generates heat? Yes, always. If you remember the olden days when you had the bicycle pump with which you would pump the air in the bicycle, if you had someone else do it for you, then that is a different matter. But if you have ridden a bicycle, you would also have used that bicycle pump to pump air into the bicycle tires. Now, after a few pumps, you would have observed that it starts heating up. It becomes warmer. Why? Because you are compressing air. Okay. Why there is subsidence but not surface inversion in this case, Suraj? Because here, see, if there would only have been cooling of the surface, it might be possible because we are in middle to higher latitude that the upper air would also be colder. It might be possible. And in that condition, the entire region would experience the same loss of heat from the surface. In the case that we are talking about, the warm air pocket is created purely because of subsidence of air. Otherwise, that warm air would not have come into existence. Subsidence, while surface inversion is occurred in general across very large areas, subsidence inversion happens only in those parts of the planet where there's a natural sinking of air. And there are certain areas where there is a natural sinking of air, which does happen due to conditions of pressure change, etc. So that is what it happens, and that is why it creates sinking of air, and that leads to inversion. Okay. Surface inversion will not happen in tropical zone because in tropical zone, rather than subsidence, you have a rise up of air. That is why. Rahul, I told you, take the case of certain areas of Europe. For example, take the case of Great Britain, take the case of Western Europe, take the case of northern portion of Russia. In all these, subsidence inversion will happen. Okay. So why a cylinder of compressed LPG is not hot? Okay. So that compressed the CNG or LPG that you have, how do you think that you gain that liquid form? Is it simply by compressing? Is it that you take that petroleum gas, you continue to compress it till it becomes liquid and you pack it up in a cylinder and it is dispatched to your home? No. Gases, they exist in liquid state at a very low temperature. So first it is liquefied, and for that it needs to be converted into high pressure. So that is why I'm telling you guys that the basics of science, please go through this. Understanding the concept of geography becomes very easy if you are thorough for 6 to class 8 level of science. Okay, right now, Then we come to another form of inversion, that is frontal inversion. So again, all of you who are having a doubt that how the change in volume or compression is leading to heating or cooling, in the same PPT, take a look back to adiabatic compression and adiabatic expansion, where we have dealt with it in significant detail. We have given the reason for that heating and cooling as well. So that is something which is present in the same PPT. Kindly take a look at the annotations. Now we come to frontal inversion. What is a front, how a front is created, all these details we will come to in the portion of cyclones and air masses. But basically, when we talk about frontal inversion, occurs in areas where warm air meets with cold air. Okay. Now, in general, again, many of you are confusing in this. When I consider two air parcels. So let me talk about the basics a bit. Let me consider this to be warm air, and let me consider this to be cold air. Now, all those who have a doubt in this, move on step by step in this case. Warm air and cold air, which will have greater amount of energy in the particles? Warm air or cold air? What do you think? Easy? Okay. What do we mean by energy? Heat, if I say heat is a form of energy, right? So when I say warm air will always have higher energy, right? Higher energy. This will always have lower levels of energy. Now, let's suppose we talk about the molecules, the air molecules. Molecules, when they have greater energy, they will start moving here and there. They will start jumping here and there. I hope you would have seen, now that these months are coming, I hope you see the television ads which come for example, Glucon-D or the glucose biscuits and the glucose supplements that you have. You'll see a kid who is generally lying around slumped, and then again, when you take in some energy drink, you start flying around. Similarly, at the level of the molecules as well, when they have a greater energy, they will have a tendency to run around, they will have a tendency to move around. So the particles, the molecules, they will start moving, they will start escaping the system. So in this region, because they have greater energy, much of those molecules will have moved away here, here, here. So in that parcel of air, you will have limited number of molecules. Because of high energy, most molecules have escaped. But what about the colder air? Colder air has got lesser energy. Molecules, even if they try to move away, where will they move? Because they have no energy. So basically, the molecules, they are unable to move away. They slump together. So that is why you will have greater concentration of molecules. Now, if I were to calculate the weight based upon the molecular presence, right? Don't worry, I'm not taking you to the portion of physical geography, physical chemistry, where we talk about the Avogadro number, etc. I'm not taking you there. But just on a layman level, if I take a look at this image by the number of molecules which are present, so which of them will have a higher weight? The one which has got greater molecules. So can we not say this is heavier? And can we not say that this is lighter? right? Now, when we talk about those areas where the warm air and the cold air, they will meet. So, rather than the preconceived notion that we have in our minds that warm air, cold air meets, they will rejoice happily ever out after, and you will have a uniform air. No, each of them have very distinct properties. Now, the warm air, let's say this is the region of the cold air. Cold air will be denser, will have a condensed weight, condensed volume which is present. Warm air, ever so expansive, higher volume. Right? Expansive volume as well. Now, this warm air is coming over and colliding with the cold air. Now, cold air is heavy. It will stick to the ground. But because there is a collision, what will happen? The warm air will be lifted upwards. The warm air will be pushed upwards. So the warm air starts climbing up here. And this will be the new position. Right? So that is how the warm air starts climbing over the region of the cold air. Now, if I were to think about this area, that whether the lapse rate is normal or whether there is a condition of an inversion here, what is it that I would arrive at? The air closer to the ground surface, you have cold, and air higher up, that is warm. It is inversion. But this inversion, has it happened because the surface is losing heat? No. Has it happened because an upper air parcel is sinking and warming up? No. It has happened why? Because the warm air has collided with cold air and has simply ridden on top of cold air. That is why. So this is frontal inversion, generally observed again across the middle latitudes, that is around roughly between 45 to 55 degrees north and south. Sometimes even 60 degrees you can take, around 45 degree to 60-degree north and south in both the hemispheres. That is where you observe this kind of a frontal inversion to take place. Okay. Now, then we have another kind of inversion which is experienced in valleys, especially in narrow valleys, valleys which are not very wide. Especially in those areas, you experience this. This is what is referred to as valley inversion. This you will experience in India as well. So in India, out of the different types of inversion that we have looked at, we experience surface inversion in the northern part of the country. Southern part of the country, no inversion, right? Because of the prolonged heat, influence of sea nearby, southern part of the country throughout the year is warmer, is hot, right? Northern part of the country, which is not surrounded by the sea, that is where you have these atmospheric phenomena which you experience quite significantly. Now, valley inversion. Valley inversion. Obviously, there is a role to be played by the valley system here. Now, I want you to follow the logic. I will bring you back to this image as well. Right now, please don't start focusing on this particular image. I will bring you to this. Apply the thing which is most uncommon amongst the common people, that is your logic. Apply your logic and you will understand this. Okay? So, before the basic question is asked, that what is a valley? Valley is the depressed portion which is present in between the mountain area. So I hope nobody takes me back to the portion of geomorphology right now. So this is a valley surrounded by two mountains. During daytime, or Why to consider daytime? Let's consider night. During night, the surface loses heat, and that is why the surface becomes cold. That is a logic we all know, right? Now here, which portion will lose heat at a quicker pace? The portion which is at an elevation or an altitude, or the portion which is at a lower level, the sea level? Which will lose heat quicker? What do you think? Okay. So, I want to ask the reason why you have given the answer, many of you that you have given, but let me directly come to the answer. So here, understand the basic phenomena. Suppose this is the atmosphere. This is the top of, let's say, tropopause. I consider a place A and a place B. B is at sea level. A, let's say I consider at an elevation of 6 kilometers from the ground surface. Okay, few mountains you have. Now, when B will lose heat, that terrestrial radiation will travel through dense air. That terrestrial radiation will travel through water vapor, dust particles, everything. Much of that heat will be retained, reflected back. There will be larger area that this has to cover while losing heat. Whereas the portion at A, it need not worry about these menial things, because above it, it has got very low amount of atmosphere, very thin layer of atmosphere which is present. So because the air above it is very thin, the loss of heat, rate of loss of heat is higher. It is faster. So rate of loss of heat is faster at an altitude as compared to the sea level. Why? Because the air is thinner. So that is why there is nothing present which can trap heat or retain heat. But near the ground surface, you will have water vapor, dust particles, gases in greater density. Everything will be retaining heat. So that is why heat loss from altitude, heat is lost at a greater rate from a height. Why? Because air is thinner. Okay, I hope this basic is clear. Now I give you the same conditions of night time, where you have the two mountains and a valley in between. So here, the top of the mountain during night time will be colder, right? So the top will be colder. So here on top of the mountain, you will have colder air. Colder air. Now, as compared to this, air at the sea level or air at this portion, in comparison, will be warmer, isn't it? Because near the sea level, it takes greater time for heat to be lost. So here, you will have warmer air in this region, or warmer air. Now, coming to the portion of weight, we know that warmer air is lighter, colder air is heavier. We know this fact. Colder air is heavier. warmer air is light. There will be a role played by gravity as well here. Anything which is heavy tends to move down. Anything which is light tends to rise up. So here, the colder air, because they are heavier, they will start sinking down the slope. The colder air will start sinking down the slope. When they are sinking down the slope, very quickly, because the warm air is lighter, lesser density, the warm air will be lifted by the colder air, and the colder air will replace the warm air as the warmer air is lifted above. Right? So, thereby at night time, the colder air replaces the warmer air at the valley bottom, and this is what leads to a condition of inversion that we refer to as valley inversion. Valley inversion, particularly when you have very narrow valleys, right? In many areas, you have valleys which are very, very narrow. So in those areas, valley inversion creates the nighttime temperature to be very low. The temperature suddenly plummets. It gets very low during nighttime. And that is why it is said that if you get stuck somewhere, never take shelter at the valley bottom during night time, because it becomes very, very cold. If that valley has got some amount of outside intervention or some amount of outside pathway, then the air can move like wind and it can moderate the temperature. But if you have an enclosed valley system, a very thin valley which has got no openings on either side, then at the valley bottom, the temperature suddenly plummets. Many of the plants at the valley bottom, that is why during night time, they will immediately start getting frozen, frostbite, and thereby they die. Okay? So that is the impact of or the occurrence of valley inversion. A quick recap: surface starts losing heat very quickly, becomes cold, cools down the air immediately above at a very greater rate, surface inversion. If you have a cold air coming from top, compressed, warmed, and thereby lies above the colder air at bottom, subsidence inversion. If you have cold and warm air meeting with each other, colliding, warm air lifted upwards, frontal inversion. If you are in a valley, the colder air at night time sinks, replaces the warm air, that is valley inversion. Okay? So that is how you have the cases of inversion. These are few of the questions, the previous year questions, a couple of questions that we will take. So I'll conduct a poll for this. So here, let me read the question first. Read the question along with me, listen to it carefully, because this is where the questions are easier. It is the twist that UPSC tends to play with the words. Normally, the temperature decreases with the increase in height from the Earth's surface. That is because the atmosphere can be heated upwards only from the Earth's surface. There is more moisture in the upper atmosphere. The air is less dense in the upper atmosphere. So, which of these reasons are responsible for the decrease of temperature with the increase in height? Saini correct. Pratyaksh and Mauli correct. Manali incorrect. Subhash incorrect. Ananya correct. Suraj, Anil correct. Shruti incorrect. Alisha correct. Karthi, Sweetie correct. Abhishek incorrect. Pranay incorrect. Okay. So again, majority of you have given the correct answer. The correct answer in this is C. So here, atmosphere generally can be heated upwards only from the Earth's surface. That is the correct phenomena. And that is something which created a lot of controversy when this question came up, because a lot of candidates were wondering about the term only, that how is it you are saying only ozonosphere also gets heated up, thermosphere also gets heated up. But then at the end of the day, who is the chief geographer amongst all of us? It is UPSC. If tomorrow UPSC takes a stance that there is no atmosphere at all, we will humbly agree to it that there is no atmosphere. So UPSC has said that it is heating from the ground surface only. That is also something that we have studied till now. So the first statement is correct. Second statement, there is more moisture in the upper atmosphere. Can this be a possibility, that there is more water vapor in the upper atmosphere as compared to lower atmosphere? Absolutely not. Majority of the water vapor is basically present in the lowest portion. Second is incorrect. So wherever you have two, eliminate that. Then the air is less dense in the upper atmosphere. That is correct. The term or the fact is correct. But then, is it responsible for decrease in temperature? Yes. So when it is less dense means lesser trapping of heat. And when there is lesser trapping of heat means what? It means colder temperature. Okay. Again, another question. Sukanya, your question that you have is so very basic that I'm afraid if I give you the answer, I might spoil the life experiences for you. So your question is that it is very cold. Is it not meant as moisture? So please understand, cold is a measurement of temperature. Moisture is a measurement of vapor which is present. Both of them are absolutely not related. They can influence each other. But when you feel cold during winter, that is not because of vapor which is present around you, my dear friend. That is basically because of in many of the cases, lack of moisture and lower air temperature. Vapor retains heat. Vapor is important in retaining heat. Okay. Now, this is another question which was asked, that the annual range of temperature in the interior of the continents, that is the continental region, annual range of temperature, that is variation in summer and winter temperature, that variation is high as compared to the coastal areas. What is or are the reasons? A, thermal difference between land and water, variation in height or altitude between continents and oceans, presence of strong winds which are present in the continental areas or inland areas, heavy rains in the interior as compared to the coastline. So I'll start a poll here. Pratyaksh, Abhishek, Sakshi correct, Shruti incorrect, Seni correct, Karti, Samantare, Vivek, Kananya. Good. Most of you are correct. Anil incorrect. Yes, I also think, Molly, most of them have already seen this question. And that is why, seen these questions, that is why many of them are getting correct. Good. So, majority of you have given the correct answer in this case as well. So here, when we say, so most of you have given the correct answer. Very good to know that you have understood the reason. So thermal difference between land and water means what? Different rate of heating and cooling. So that is correct. It is because of this that you have interior areas like Delhi experiencing higher temperature during the summer and lower temperature during the winter, where areas around Mumbai, they will have moderation. Variation in altitude, height between continents and oceans. Is that a reason for temperature change? We have till now not even covered the altitude of the coastal areas. Many coastal areas or many areas in the interior, they are at the sea level, but still they will have extremity of temperature. Many areas across the coastline, they are at an altitude, but still they will experience moderate temperature. So in the coastal areas, altitude is not a factor of play. So second is incorrect. Very, very incorrect. Second is incorrect. Wherever there is 2, eliminate that. You get the correct answer. Okay? Right. So all those who have solved it by elimination, that is the way to go forward. That is something you should be pursuing. Okay? Now we come to the atmospheric circulations. Now, this is again very relevant for your examination, but more so if you want to understand the concept of El Nino, La Nina, if you want to understand the concept of tropical cyclones, temperate cyclones, if you want to understand the concept of maybe jet streams, Indian monsoon, for all these concepts, this is a portion which is very important, even for world climatic classification. So here, this is relevant for your prelims as well as for your mains exam. Okay, Chinmay, you want me to elaborate on the third and fourth options as well? Okay. Presence of strong winds in the interior, the third option. In general, you will experience much stronger winds in the region of the coastline because there is lesser resistance for the wind flow in the sea. That is why coastal areas experience stronger wind as compared to the interior areas. Anyways, if there would have been stronger winds, still that would have brought moderation of temperature rather than extremity of temperature. So third is also incorrect. Heavy rains in the interior as compared to coastline, that is always incorrect, because always the coastal areas, because of influence of the sea, they will experience more recurrent rainfall. Okay. Now, Suraj, my dear friend, please don't use the term insulation. When you are referring to geography, please never refer to the term insulation. Refer to insolation. I hope by the end of the climatology and by end of geography, you don't refer to this term insulation ever again in geographical terms. Use insulation when you are talking about wires, when you are talking about getting heat shock, electric shock, use the term insulation. But when you are talking about sun, earth, and these basic things, please don't use this. Okay. Now, prelims, this is important. What is important from here? Basics of wind movement, permanent winds and local winds, winds and local winds, and also pressure belts. Okay. Now, in the portion of the mains, you get questions from wind patterns and model of air circulation. Okay. Now here we are going to discuss and talk about how is it. Till now, in the previous module, we have looked at the basic concepts. The basic concepts that how heat is received. How is it that different surfaces react to the same solar insolation? How is it that different altitudes react to the same solar insolation? How temperature changes. But all this leads to the initiation of wind movement. Wind moves from one region of the planet to the other consistently. Whenever you step outside your house, sometimes you would experience that wind. There you would have experienced that not always is the case that the wind that you face, for example, right now or after the session, if you step outside your house, experience the wind, observe it. Now, it is not the case that, let's say, throughout the year, you will get the same velocity of wind, you will experience the same temperature in that wind, and also the direction. All these things, they keep on changing, and that changes across the planet. These winds, they are very, very important in distribution of heat and also inducing various climatic conditions and phenomena across the entirety of the world, be it the region of Western Europe, be it the region of northern part of North America, or be it a country like India. India is, and we can say in a nutshell, that India's entire economic setup is dependent upon the wind movement, because it is the wind movement which we observe during different parts of the year that brings us the monsoonal rain, and that is what brings rainfall distribution in various parts of the country. So that is why it is very important for us to understand how the wind pattern behaves and how the circulations take place. But before that, we need to understand another basic concept when it comes to climate. Till now, we have looked at the concept of temperature, insolation, isotherms. Now we take a look at another related concept, that is air pressure, atmospheric pressure. What is pressure? You as candidates of civil services, I don't think you need anybody to tell you what do you mean by pressure. Pressure is something that you are experiencing on a day-to-day basis. But then when we say atmospheric pressure, in general, what do we mean? Pressure, which is represented by the term mass per unit area or force per unit area. It is the amount of force which is applied on the surface anywhere. So when we say atmospheric pressure, the air particles which are present, they will also exert a force. They will exert a force on the ground surface. So that is what is referred to as atmospheric pressure. If I consider the normal air, normal conditions. Now, in these normal conditions, the air will have various different particles, molecules which are present here, isn't it? All of them will be able to impose their weight. They will be exerting their weight. That weight will be exerted where? On the ground surface. So what you experience on the ground surface, that is something regarded as atmospheric pressure, right? In simple terms. So if I take you to the written portion, the definition portion, weight of the column of air contained in a unit area from the mean sea level to the top of the atmosphere is called the atmospheric pressure. The atmospheric pressure is expressed in the units of millibar in general. At sea level, the average atmospheric pressure is 1013.2 millibar, which is also represented as MB. Okay, millibar. Now I bring you back to this image. Now, a couple of slides earlier, we had reached a kind of a deduction, and that is warm air will have lesser density of particles, will be lighter. Cold air will have greater density of particles because of lower energy and will be heavier. We had reached this, right? I will use the same derivation and the same perspective. So we know that when we talk about cold air, generally greater density, isn't it? So when you have greater density of particles, in the colder air. So they will impose a weight on the ground surface. That will be the atmospheric pressure felt in that region. On the other hand, when you consider a region which has got warm air, that means there will be lesser density of particles. Now, what is air pressure? The weight imposed on the surface is air pressure. Now, if I compare it, and this is something which is very like logical, just by looking at the image, you can come at this derivation. If I consider these two places A and B, and I consider the column of air above, where is it that more weight is being imposed? At A or at B? Where do you think? A, as easy as that. So, can we not reach a conclusion that colder areas experience higher pressure? Or rather than this, let us understand that there are multiple different exceptions in this case. So let's not use this. Let's use another terminology. And this tells you that how one term can make a lot of difference here. We can say colder air exerts more atmospheric pressure. In general, also we know cold air has a propensity to sink, warm air has a tendency to rise up. Now think about it and listen to this carefully. Let's consider this to be the ground surface. Now here, if I have a warmer air, warmer air is lighter. If this is warm, warmer air is lighter. Anything which is lighter tends to rise up. So in this place on the ground surface, I have an air column which is rising up. So what is the weight experienced on my hand? The weight will be reduced. So the pressure will reduce, right? On the other hand, if I have a colder air somewhere, cold air, because it is heavy, will tend to fall, will tend to sink, and that will indicate a greater pressure. So colder air generally exerts more atmospheric pressure, and warmer air exerts lesser pressure in general. So in one area, you will find there is an excessive presence of air particles, molecules, etc. In other area, you will find a relative deficiency. So generally, you will find that the excess ones, they will go there to fulfill the deficiency. So there is a kind of an air movement which will be induced. This air movement, which is induced in between different pressure areas, that is what we experience in the form of wind. So every time that you experience wind on your face, understand that the air is moving from some place of high pressure to some place where there is low pressure. Always. There is no condition under which you will have air moving otherwise. It is always due to the pressure difference. Now, this pressure is dependent on many factors, temperature being one of the major factors. So, pressure is dependent on many factors. One is temperature, another is movement. of wind. We will study both these cases, that how despite the temperature factors, movement of wind induces different pressure, and how temperature significantly leads to variation in pressure. So we will take a look into both these factors. So first of all, when we take a look about wind and air circulation, so that is something I think we should look into tomorrow. Today, I want you to take a few areas for map pointing. So that is again something I need you to take a look into. So this is where we'll restrict the session for today, guys. I hope that today's session was something that you extracted out of and it was meaningful for you guys. And any doubts that prevail and persist, feel free to get in touch with us. Here, but sir, retain nahi rahega. So for that, revise. Please do revise if you want to retain. Okay. Now we go to maps. Few areas I want you to look into the map and understand where they are. So first of all, start with Hudson Bay, Gulf of Mexico, Bering Sea, North Sea, Kara Sea, then Baltic Sea, Gulf of Bothnia, then Mediterranean, Patagonian, Peninsula, then few of the deserts also, Atacama Desert, Namib Desert, Kalahari, Dastelut Desert, then also Thar, you already know, Victoria Desert, Gobi Desert. Okay, then also Sea of Japan, Ross Sea, and Gulf of Carpentaria. Locate these places. We meet again tomorrow. We will continue our discussion for the portion of wind circulation, air circulation, etc. Okay, now let me take a few questions here. Payal, you had a question for surface and valley inversion. Surface inversion, Payal, occurs when the surface loses heat, becomes so cold that the air above it also becomes colder than the air above. So that is what creates the surface inversion, generally observed during long winter nights. Valley inversion happens when you have cold air from top of the mountains, they descend down to the valley bottom, they replace the warm air at the valley bottom. That is when we have valley inversion. How absence of winds are responsible for surface inversion? Basically, when you have the winds which are present, they distribute heat, right? So the absence of wind ensures that the temperature is maintained, or whatever is happening continues to happen. Okay. Kivika, I want you to look at the places, the region around it. I need you to be mentally aware that where these places are. Okay. The region around it. For example, Baltic. When I say Baltic, you have to look at which are the countries: Estonia, Latvia, Lithuania around it. That is how slowly and steadily your perspective will build up. Biswajit, subsidence inversion is when the air from top starts sinking. In that process, it undergoes adiabatic compression and heating, due to which it becomes warmer. The ground level air is colder due to winter conditions, and that is how you have again a condition of inversion. Okay. Right. Rahul, please explain two option in the last PYQ. That is, see, understand. And this is where I want you guys to understand that in majority of the questions that we do wrong, it might seem that I'm saying anything out there. Listen to this carefully, my dear friends. Why is it that we do questions wrong? Is we don't answer the requirement of the question. We answer what we know, right? Here, what is the question? The question is, why is it that a region, if I suppose this is the portion of the Indian peninsula, why is it that, let's say, I consider Chandigarh? Why will Chandigarh experience greater variation in summer and winter temperature as compared to, let's say, Vishakhapatnam? Why is it so that Chandigarh will experience higher summer temperature and lower winter temperature? That is what annual range of temperature means. What is your second option given here, Rahul? Read it carefully. Variation in altitude between continents and oceans. Yes, there is a variation in altitude in continents and oceans in many of the places. But if I give you the location of a place, let's say Patna, very close to sea level. Vishakhapatnam is also close to sea level. So does that mean Patna will experience the same temperature as Vishakhapatnam? No. There will be extremity of temperature. Summer will be very hot, winter will be oppressively cold. So that is where altitude is not the factor. The fact is that water and land, they heat at a different rate, which generates the movement of wind on a daily basis, due to which you have the retention of heat and moderation of temperature in coastal areas, and that factor is absent in the interior. Okay. Frontal inversion, Ankita, is basically when you have hot air and cold air, they collide. Hot air is simply pushed upwards, due to which you have the inversion. Now, where a front occurs, why this will happen, we will come to it. In the next couple of modules, you will get to know. Okay. Yaram Seti, see, I can make that table of cold and warm air. I would have made it in the first slide itself. The reason I'm not making it is I don't want you to memorize it. I don't want you to rote learn it. Because the moment you do that, you will get confused. Eventually, you will commit mistakes. Understand it organically. We will go one by one. Organically, we'll repeat it so many times. You will understand. Warm air will always be lighter. It will rise up. Understand the reason behind it. If something has got more energy, the molecules will move greatly. And when the molecules will move greatly in that sample space, the molecules will escape from it. So in that sample space, you will have lesser molecules which are lighter, rise up. Ranjan, it is always the land area which cools down quicker, which heats faster as well. Sahil, despite of reading every annotated PPT, I got out of 20 in weekly test one. What should I do? So, Sahil, listen to this and follow this. And this you can use for other subjects as well. Many of you will be experiencing that you are not getting so many questions correct. When you get an objective question incorrect, analyze it. Let's say out of a paper you get 10 questions incorrect. 10 questions are those which are incorrect. Now divide those, analyze those. While analyzing, divide those questions. Why is it that MCQs get incorrect? There are only certain reasons why you will get an MCQ incorrect. Either there is a lack of content, you don't know what the correct answer is, or there is a lapse of concentration. Only in these two reasons you will get a question incorrect. Put the questions, that how many questions are there in this portion due to lack of content, how many questions are simply because you knew the correct answer but somehow you committed a silly mistake. Wherever there is a lack of content, revise it again through the answer, through the analysis, through the explanation. Go to the root of it, understand it so that you don't forget again. And then slowly and steadily, by more practice, this portion can automatically be curated. That is how you will benefit from these tests. These tests are not for you to be able to score, okay, out of 20 questions, I got 19 correct, 18 correct, fair enough. But this is how your self-improvement will take place. Follow this eventual game on the prelims day, you will succeed. So with that, I end the session for the day. Any doubts which persist, feel free to get in touch with us. We'll get back to you. Tomorrow we meet again and we discuss the portion of air circulation, and also we will move into the area of cyclones. Thank you. Take care of yourself. Goodbye and have a good night.